Hello, welcome to the first part in this series on how to build your very own basic programming language interpreter in Python. In this video, we'll write a few functions to evaluate arithmetical expressions using recursive descent parsing algorithm. The idea is very simple. We'll split an expression string into tokens, and depending on token type, we'll be taking a certain action, meanwhile deleting the token we've just parsed. Although evaluating expressions on the fly like this might not be the fastest approach, still, it's very simple, straightforward, and quite intuitive to understand. So without further ado, let's go for it. Okay, so I start with creating a new file called basic.py, and this is going to be a basic interpreter, okay? And I will now create a global variable called token. So token is equal to, and just an empty string for now. So I know it's not a good idea to use global variables, but again, for the sake of simplicity and clarity, I will go this way. So no object-oriented stuff, just the straightforward functional approach. Okay, now let's define the function called scan, and it would be taking a line as an argument. So what this function is going to be doing is the following. So every time we want to retrieve a new token from the string containing our expression, we'll be calling this scan line, and in return it would initialize the token variable with either a number or like plus, minus, multiply, divide, or this might be something else when it comes to statements and so on. So scan line is going to return the next token to deal with. So in order to make sure that we do exactly deal with this global token variable, I can say global and token, and I can say that if the length of the line is equal to true, so if there is still the line there, so because we're supposed to be deleting the tokens by the time we're passing them, and the line indexed by 0 is digit, so we are dealing with a number. So in this case, we're gonna say that the token is equal to number and sending the line as an argument. We'll now create the number function here, and otherwise I say elif, and again the length of the lines, and make sure the line is still there, and line indexed by 0 in the following list. So it might be either plus, minus, multiply, divide, parentheses, equal sign, less or greater signs. So in this case, what we want to say token is equal to operator and sending the line as an argument. Okay, now let's define these functions we've just called. So first, let's start with the operator. That's the simpler one. So def operator, and it takes the line. So what it does is very simple and straightforward. So operator is going to be equal whatever line indexed by 0 is, and then we want to delete the line indexed by 0, okay, and finally we want to return the operator. Simple and straightforward. And now def number, and again takes the line as an argument. So this one is going to be a little bit more complicated. So I want to define the number equals to 0 and the token equals to empty string for now. And now I say while, and the len of the line is true, so the line still exists there, and line indexed by 0, the first element, is digit indeed. In this case, we want to do the following thing here. So we say talk plus equals whatever line indexed by 0, so adding digits to the token, and then we want to delete line indexed by 0, and then want to say that the num is going to be equal to integer and whatever our token is. So that's it. So now we want to return the num. Great. The next thing is to say def factor. So the factor is the basic building block. So line is taken as an argument. So here we do distinguish between the type of tokens that can be returned by the scan function here. So I can say if the type of the token is equal to integer, this means that we are dealing with a number. So in this case, we just want to return the token, right? Then it might happen that if token is equal to opening parenthesis, in this case we want to say scan line, so we are sort of eating this parenthesis, scan line, passing through the parenthesis here. Then we want to say a equals to expression and line. We don't yet have this function expression, we'll define it a little bit later. Okay, and now we can say if a is equal to none, so if the expression doesn't sort of work, in this case we just return none. Now we need to make sure that the token is the closing parenthesis once we got done with evaluating whatever was after the opening parenthesis. So I can say if token is equal to closing parenthesis here, we want to return a, and otherwise this means that sort of a syntax error, so we just say else and return none. Okay, now also it might happen that say elif token is equal the unary minus this time. So if there is the unary minus, I want to scan through it, so like eating this token, yeah, and then scan line, and then just want to return minus and recursively calling factor itself with line wherever is still available there. And otherwise we just say return none, which means that we have encountered something that shouldn't be treated as the factor, hence return none, hence this is going to be an error. Okay, now if we have one or more factors being sort of concatenated together, that's the matter of calculating a term. So let's say def term, and it takes the line as an input here. And first we need to get the first factor, so I can say a equals to factor and whatever the line is, and then we are entering the loop, so I say while true. So the idea behind this loop is very simple. So it might happen that there is not just like one factor multiplied by another factor or one factor divided by another factor, but like factor multiplied by factor multiplied by factor divided by factor, and so on and so far. So hence the loop here. So once we've entered the loop, we need to say scan line, right? So this initializes the token with the operator. There should be an operator, otherwise that would be just an error. So initializing the operator, so now token should be either multiply or divide, and we check these cases. So I can say if token is equal to multiply, this case we passing through this multiplication, and then we are initializing the second factor is going to be equal to factor and the line. And finally, we can say a equals a multiplied by b, right? Now, very similar for division, so if token is equal to divide, in this case again just scan token, and again b equals to factor and line, this time a equals a divided by b. And since we're dealing with integer arithmetics only, I want to say int here, because if that's the floating point, it's like much harder to parse because there's the floating point itself. Yeah, so just for simplicity we keep it integers. So say else we just want to return a. Okay, now if we have two or more terms, we can do plus or minus operations with it, and that's the matter of evaluating the actual expression. So I can say def expression, and again it takes the line, and the structure is very similar, but now we say a equals, this time we want to say term, and the line like this. And now again while true, because there might be multiple terms being encountered. So here we can already say like if token is equal to plus, because the token variable should already be initialized at this point to either plus or minus. And here I can simply say scan and line to scan through this plus symbol or minus. Calculating the b expression, which is going to be equal to term, or b term to be exact, and line here, and we say a equals a plus b. Now I can say elif, and yeah, by the way, also elif here, so elif token is equal to minus, same thing here, so scan line passing through the minus, then b is equal to term and the line here, and here a equals a minus b, and otherwise we are done, so we just return a. Now finally, let's create a function called def calc, also takes the line as an input. So here the idea is that we want to do a sort of an error handling here, so I can simply say try, and I can say result equals to expression, and send in the line as an argument here. So if result is not none, so remember we did return none in case if something gone wrong, so in this case we just want to return result, right? But otherwise we want to prompt the user by saying print, and just briefly say that this is a bad expression, which means that something has gone wrong and the format of the expression is not correct. Although not the very detailed sort of explanation, but still should be fairly enough to give a user an idea that something has just gone wrong. And also want to accept the following. So here print, just want to make sure that execution failed. So when it comes to the loop within like looping over the lines within the buffer, where every line would be like a source code for our basic program. So let's say we've been evaluating some expression within that line, something has gone wrong, execution failed, and we will drop back to the main loop. So just to give an idea. Now already with this tiny amount of code, we can actually go and test it. And to make sure that we have the properly working evaluator, we need to check this with the built-in eval function available in Python. So let's just define the line here. So line equals to, and I just put some quite a sophisticated expression here, and I want to say print and eval and the line. So here I just say should be and yeah, it's probably result should be like this, and print result is, and here I can say calc and our line. But before this, this is not going to work that way. I also need to make sure that I do the scan line for the very first time, because before that there is nothing in the token variable. But once we call this scan line, token variable is going to be equal to this unary minus, and then it would be like eating token by token, and the expression is going to be evaluated on the fly. Alright, so I hold my breath, write, quit, and I say Python 3 basic py. Let's have a look. Okay, something wrong with the indentation. Let's have a look. 37. What it doesn't like. Yes, like this. Okay, result should be 101. Something wrong. Okay, yeah, this happens the following way. So we need to do some more preparation here. The idea is that currently our line is just a string but doesn't support deletion. So after we did this, we also want to say that line equals to character for character in line, and we also want to strip the spaces, because yeah, it's not going to work properly with the spaces. So line dot replace, and white spaces to be replaced with nothing here. So yeah, this should now work. Okay, for okay, execution failed, result is none. Okay, something has gone wrong here. Yeah, we got this variable should be tok, not tol, not a typo. And let's go. Okay, horrible bug here. Obviously we scan not the token but scan the line to initialize the token. Yeah, and let's try again. Okay, result is 101, and I already know that's exactly the result. So let me just make some cleanups here. Just delete this debugging info. And yes, also I do not want to print this line here. And here we go. So result should be 101, sorry, and the result is indeed 101. So since we have the integer only arithmetics, it doesn't print the floating point, while originally Python does convert the integer to floating point type every time it encounters division. Okay, so that's it in regards to evaluating expressions. So the next video will enhance the functionality a little bit, and we'll add variables so that we can also use variables within the expressions. Now that being said, this is it from my side. Thanks for watching, and I'll see you in the next video.